Hey guys, in this video we are going to discuss sequences. Actually, a sequence is a list of numbers written in over this way, right? So the number of elements in this set, in this sequence can be finite or infinite, right? So for instance, if you roll a die 6 times, you get a finite sequence, right? So we know that a die has six heights. So when you roll a die, get something like 2, 6, 1, 3, 3. There's another 6 times. Yeah, you get a sequence like this. This is called a finite sequence because it has finite number of elements. If you have an infinite number of elements, we call it infinite sequence, right? Actually, infinite sequence is a function. It's a function from natural number set to real number set. Alright, so the sequence is a function from natural. If you talk about infinite sequences, so that sequence is a function from natural number set to real number set. So the first element, let's say this is your first element 1, this 1 maps to a number in the real life, some number. This could be 10, 100, 1000 or million. Each number in the real in natural number set maps to a real number. You look at this one here. So this is a number, and this sub 1, so this is the first term. First term maps to this element in the real life. Second, yeah, so 2 maps to this number, and 3 maps to this number in the real life, and 4, 5, 6. So this is an infinite sequence, right? So we call this is the first term of the sequence, this is the second term of the sequence, third term, and so on, right? For instance, look at this one here, 1, 2, 3, 4, 5, 6, and this goes on, right? So the first element of this sequence is 1. It is denoted by a sub 1, right? A sub 1. This is the second element in the sequence. It is 2. Then if you suppose this has a pattern, but so it is noted that a sequence does not have a pattern. It does not have a pattern. Suppose we assume this sequence has a pattern, right? Then notice the pattern, 1, 2, 3, 5, 6, increasing by 1. Then this is the first term, second term, third term, fourth term. Then you can write the nth term of this sequence, which is this, if this sequence has a pattern. For instance, a sequence does not have a pattern. So if you roll a die infinitely many times, you get random numbers in between 1 and 6. Yeah, so it doesn't have a pattern, right? So that's why some sequences have patterns, but some don't have, right? Right? Keep in mind that, right? So you have to keep that in mind, right? Look at this one. So this one does not have a pattern. So here, if I roll a 20-sided die repeatedly, I can generate the sequence of numbers, but which have no pattern, right? Because it is random. We don't know what will come. What will come? We cannot decide that. So generally, a sequence does not have a pattern, right? If you assume a sequence has a pattern, for instance this one here, look at this pattern. Notice this pattern: 1 negative 1 1 negative 1 1 negative 1. The first look at the even terms. This is the odd term: first term, second term, third term, fourth term. The position of even terms, it takes 1, and otherwise it takes negative 1. So if this has a pattern, right? We assume this has a pattern. Then you can write the nth general term of this sequence. So what is the general term? Suppose a sub n is denoted by the general term nth term of this sequence. So if n is equal to 1, this should be equal to 1, right? Keep that in mind. Then negative 1 to the power n plus 1. If you put n plus 1 here, so if you sub 1 into here, you get here negative 1 to the power 1 plus 1 is 2, negative 1 to the power even exponent. Then this becomes 1, right? Then the first term is equal to 1, but the second term is negative 1, and this is an alternative sequence. Here the sign of this sequence changes. Here look at the consecutive elements. This notice the sign of consecutive elements. Here this is positive, this is negative, positive, negative. Alternating the sign, right? So if you assume this has a pattern, then you can write the general term of this sequence, right? All right, let's consider another example. Let's say we have a sequence like this: 1 negative 1 over, no, positive, all are positive terms, 1 over 2. This one is the second term of the sequence. This is the first term, second term, and third term would be 1 over 3, and fourth term. Alright, this goes on, right? If you assume this has a pattern, so what is the general term? The general term of this sequence is 1 over n, 1 over n, a sub n. This is the general term. Nth term of this sequence is 1 over n. Pretty simple, right? If you look at this sequence here, this is the first term, second term, third term, fourth term, fifth term. Look at the pattern. If you assume the sequence has a pattern, So what is, can you write down the general term of this sequence? So let's denote the general term by n sub n. This is the general term. So a sub 1 should be equal to this. This is your a sub 1. This is your a sub 2. This one is the a sub 2. This is the 1 minus quarter is a sub 3. Now I want to write the general term of this sequence. When you plug 1 into here, I want to get minus 1/2. So how to get, to plug 1 into the equation, into this expression, I want to get minus 1/2. Look at this. When you plug 1 into the expression, negative 1 to the power 1 is negative. You get this. You look at the sign. Sign is alternating here. Negative, positive, negative, positive, negative. That's why I put negative 1 to the power n. If this n is odd, this becomes negative. If this power is even, this becomes positive, right? That's why I write, if you see an alternative sequence, the sign changes. If you consider here, look at the minus 1 positive, minus positive, negative positive, negative positive, and so on. Then you have to add this term here, minus 1 to the power n. So when n is an even number, this becomes positive. When n is an odd number, this becomes negative, right? First term, when you plug 1 into the expression, left hand side is a sub 1, the right hand side is negative 1 to the power 1, which is negative. 1 over 1 plus 1 is 2. You get this one. You manage to get the first term and plug the second. If you want to find the second term from the general term, so all you need to do is plug 2 into the expression. When you plug 2 into the expression here, left hand side is a sub 2r. That is the notation for second term of the sequence. That means this. Let's look at the right hand side. When you plug 2 into here, when you replace 2 here, so negative 1 to the power 2, which is positive 1, right? This so positive 1 times 1 over 2 plus 1, which is 1/3. I think you understood this bit. So when you say, if you assume, here we assume that these sequences have pattern, right? Otherwise you cannot write the general term like this. We assume that if you are given a sequence, it doesn't need to be having a pattern, right? But here we assume that these sequences have a pattern, right? Alright, then you can write the general term here. By looking at this one, you can write the general term. Here look at this bit here. So this is the first term, second term, third. First term, this term starting off with 2. Look at the numerator changes. Even number, it takes even numbers here. 2 are not even number. 2 to the power something here, 2 to the power something, 2 to the n, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. So the numerator, if this sequence has a pattern, then you can write the general term. The numerator very easy, which is equal to 2 to the n. The denominator, look at the denominator, are 1, 2, 6. Look at this, factorial 1 is, factorial 0 is 1, factorial 1 is 1, factorial 2 is 2, factorial 3 is 6. That this is factorial 3, this is factorial 4, 5. Then you can catch the pattern. Alright, this is the general term of the sequence if it has a pattern, right? You assume that this sequence has a pattern, then you can write the general term like this. So you can represent a sequence in many ways. For instance, some people write in this way. Here they give these things. This is the first term, second term, third term, and they give the general term like this. Nth term, this is the nth term. Or maybe you can represent this way. So they give only a general term here, or this way, right? So we can say, or we can consider, let's consider a sequence. We can write like this. We consider a sequence A sub n, and whose so an is defined by this. You can represent, you can use either one, right? So people use either one of them, right? As I said before, a sequence, as I told you before, a sequence is a function from positive integers to the real numbers, because here, so this is the mapping. First term maps to this number, second term maps to this number, third term maps to this number, and nth term map to this number, and this goes on. So here you have a, because we are talking about infinite sequences, so here we have this relationship. So sequence is a function from the natural number set to the real number set, right? So that function is defined as this here. If you consider any general term, this is the nth term that maps to that one maps to this number. So this is a, so sequence is a function from the natural number set to real number, as I said before, right? You can see it graphically, right? So this is your, wait a second, right? So this is your real number set. This is your, here, this is first term, second term, third term, fourth term, fifth term, and this goes on, right? The first term maps to some number in this real line. This is your real line. So let's say this maps to somewhere here, this number here. This is your real line. This is your first element, first term of the sequence. So we denote that one as a sub 1. A sub 1, this is your first term. Second term maps somewhere, let's say this. This is your a sub 2, and like that. This is your third element, fourth, fifth, like this. This is your nth one, and this goes on. This goes on because we are talking about infinite sequences. All right. So if you look at the graphs of this one here, so they plot, so this sequence here, this is an alternative here, so odd even, odd even, odd even. If you take, so if n is an odd number, this takes negative. If n is an even, this is a positive one. Well, first term is negative, first term, because 1 is odd, so here negative 1 to the power 1 is negative 1 divided by 1. First element is negative 1. This is the second element. When you plug 2 into here, so minus 1 half is the second element, right? Like this, alternative. So this is the graphical representation of this sequence here, right? You can do this one, right? I think to understand, if you want to understand what a sequence is, just plot that one first few terms, then you can get an idea. I think some people haven't done sequences, some people did sequences last semester, right? There are new people who are doing this numerical analysis, right? Normally, when you talk about sequences, we are not interested in initial these parts. So we are interested in the limits of the at infinity. So what number this limit converges to as n tends to infinity. When n tends to infinity, what happened to this sequence? So you know that this is your numerator. That means here, look at this. This is your numerator here. Numerator is alternating, right? Positive 1, negative 1, positive 1, negative 1. But look at the denominator here. You have n. As n tends to infinity, your denominator becomes bigger and bigger. What happened to the number? This number becomes very small, become smaller and smaller. That means the sequence approaches 0, right? This sequence converges to 0 as n tends to infinity. So look at this one here, this sequence. So you can simplify that. So this is the general term of that sequence. Nth term of this sequence. Just simplify that. So here you have n cubed 2 times n cubed minus 1 divided by n cubed, right? Just simplify that term. A sub n is 2 minus 1 over n cubed. Alright, so 2, here 2 is a constant. So it doesn't change here, right? But here, look at here, you have this term 1 over n cubed. As n tends to infinity, what happened to the denominator of this term? Denominator gets larger and larger, then this number becomes very small. So this number is negligible as n tends to infinity. Then this sequence converges or approaches to like this. This is the graphical representation. Here there are finite, there are only 100 terms. Here look at the variation here. This is the first term, second term, third term. As n tends to n becomes very large, this sequence approaches 2, right? So n takes a larger value, then this is negligible, then this sequence approaches to, right?